All right. In this example, we're going to be looking at a few concepts from coordinate geometry. Now let's take a look at this diagram. This is an equilateral triangle, and we need to find out the center and the radius of the encircle inscribed. That means we need to basically find out the midpoints, because in an equilateral triangle, the edges of the circle touches exactly at its midpoint. So that means we need to find out midpoint of this side, midpoint of this side, and the midpoint of this side. Now the advantage here is if you find out any two sides, it's enough. It should help us solve the radius, the center and the radius of the end circle. So to start, what I'll do is I'll first label my diagram. So let me call the top side as A, the left edge as B, and the other edge as C. Just to make my life easy, I'll only work with two sides starting from side A. So from A to B, and I'll work from A to C. So as long as I get two sides, I should be able to get my answer. So what is my step one? My step one is going to be to find out the midpoints. So my step one is finding the midpoints. Now, there is a formula for midpoint. So midpoint, I'll use the letter M for now. You can write that as x1 plus x2 over 2, y1 plus y2 over 2. So that's going to be the formula for midpoints. On my diagram, just to make things clear, what I'll do is I'll use the letters M1 here and M2. That means my intention is to find out M1 and M2. So let's go ahead and find out M1. So what I'll do is I'll try and use a different ink, maybe red. All right, so since I'm starting from point A, I'll use this point as my reference x1, y1. And since I'm finding M1, this point A has to be measured with point B. So this guy is going to be called as x2, y2. So let me go back, change the ink. All right, so back on my formula. So what I'll do is I'll write the corresponding numbers. So my x1 is 20. So I've got 20 plus 10 over 2. And I've got 40 plus 20 over 2. That means my midpoint 1 is nothing but 15 and 30. So I can come back here on the diagram and write the measurements as 15 and 30. So this is going to be done exactly the same with M2, except that your x2 and y2 changes to this variable. So I'll go ahead and do that now. So yeah, to find my M2, the first thing I'm going to do here is write this variable as my x2, y2. Let me change the ink. So I'll go back to black. All right, so again, what I'll do is I'll write as M2 equals, I'm going to start putting in these variables. So my x1 is still 20, so 20 plus 30 divided by 2, and 40 plus 20 divided by 2. So my M2 is 15 and sorry, it won't be 15, it's 25. Apologies for that. So it's 25 and 30. So I'll come back here at my M2 and I'll write my new coordinate, which is 25 and 30. I mean, I can actually go back and refer to see if this makes sense, because you see here, I'm going along my x-axis. If this midpoint is 15, this cannot be 15. So you see it's increased by 10, so it's 25. So it's foolproof. That's good. So we found the two midpoints. The next thing I need to do is my step 2, which is finding out the slopes of these lines. So finding the slope of the lines. Slope of lines we chose AB and AC. Now slope also has a formula. That means what I'll do is I'll write it as S. A lot of teachers also use M, but don't be confused, it's still the same thing. So I'll write it as y2 minus y1 divided by x2 minus x1. So I'll first find out my slope 1. Now what is slope 1? That is nothing but along this region. So I'll put this as my S1. So what I'll do is I'll go ahead and change the ink. I'll probably again go and put my x1, y1s just to not get confused. I'll write my a variables as 1, so x1, y1, and x2, y2. And I'm going to put these values in my formula. So my S1 is nothing but 20 minus 40 divided by 10 minus 20. So this is going to give me a negative 20 divided by negative 10. In other words, my S1 is a positive 2. I didn't look at it. Apologies for that. Digital pens are not as good as real markers. So yeah, so my S1 was a positive 2. Now the other thing I need to do here is I need to find out the slope of its perpendicular. In other words, I found out the slope of this line, but actually you need the slope of the line going towards the center. So that means what I'll do is I'll go ahead and finish that off here. So slope of perpendicular 1 is nothing but negative 1 over slope of 1, which in our case is negative 1 over 2. So this one is very important for us, and this is what is going to be used to find the equation of the line. So I'll put this in red ink because the slope, we're not looking at just the slope of the line, we're actually looking at slope of its perpendicular. So to find out S2, let me put the new variables. So this is going to be my x2 and y2. So let me use that in the formula. So my S2 is nothing but 20 minus 40 divided by 30 minus 20. So this is going to give me a negative 20 divided by 10. In other words, my S2, the opposite, it's negative 2. So that means the slope of the perpendicular for line 2 is nothing but negative 1 divided by S2. In other words, it's negative 1 divided by negative 2, which is positive 1 over 2. And this is something that's again important for the next step. Let me go ahead and put this within the good box. So I've got the slope of line S1. Let me do those changes as well. So let me put that here and go back and okay. So let me do one thing. Let me first approximately put a center. Okay, and I've got, let's say for example, a line passing to the center in both these cases, and let's say the point is O. So this line had a slope of -1/2, and this line has a slope of +1/2. So this is the perpendicular for S1 and the perpendicular for S2. Now, generally, in most cases, if you can show me the midpoint and the slope of the perpendicular, you generally get your achieve. Now let's go to step 3. We found out the midpoints. We found out the slope of the perpendicular. That means the next thing that we need to find out is the equation of the lines S1 perpendicular and S2 perpendicular. So what I'll do is I'll write the word here as equations of the perpendicular line. Now the general equation of a line is given by y minus y1 equals the slope times x minus x1. So what I'll do is I'll come back to my diagram, and I need to choose the slope. I need to choose the x1 and y1. So by just looking at my diagram, I can say that now let's work with S1. So that means this guy, it has to be my x1, y1, and this one is going to be my s. Slope is -1/2. So I'll use this in the formula. So I'm going to come here, write this as y minus 30 equals -1/2 x minus 15. I'm going to simplify this. I'm going to get 2y minus 60 equals -x plus 15. All I've done is I've opened the brackets and rearranged the denominators. So I'll bring this in the form of maybe y equals mx plus c, so the standard form. So what I'll do is I'll first write this as 2y equals -x plus 75. All right, so to find out the next equation for the next perpendicular line, I'll again do the same thing. So I'll take this as my reference. So this is going to be my x1, y1, and this is going to be my slope. So let me go change the ink. Let's do it. So what I'll do is I'll write it as y minus 30 equals -1/2 in this case. Oh, sorry, +1/2. And open brackets, x minus 25. So I'll write this as 2y minus 60 equals x minus 25, or 2y equals x plus, this is going to be 35. All right, so let's go to step 4. So step 4, I'm going to solve the two equations of the perpendicular lines simultaneously to get the values of x and y. So that means it's going to be simultaneous equations. Now what I'll do is I'll grab both my equations in the non-simple form. So let me just refer back to what I'd written before. And I'll go back and write the equation of the first perpendicular line, which was 2y equals negative x plus 75. And the equation of the second perpendicular was 2y, I think, equals x plus 35. So I'm going to refer to these non-simplified form equations. So I'm going to use them. I'm going to solve them simultaneously. That means when I subtract the two equations, I get a 0. I get this equal to negative 2x, and this equal to a positive 40. That means my 2x equals 40. That means my x equals to 20. So the x coordinate of the center is 20. Now to find out the y coordinate, just put this x value in any one of the two equations. So for example, I'll put it in the second equation. So in this equation, 2 times y is going to be equal to 20 less 35, which is 55. Or in other words, my y is going to be equal to 27, I hope I'm right, should be 27.5. So that means the y coordinate should be 27.5. That means the center of my circle is 20, 27.5. Now the last step is to find the distance between the center O and any one of the midpoints. I'll probably choose this value. So let's say O M1. So distance O M1, and this one is my step 5. So I'll probably put this as 5. Now the distance formula is given by distance equals square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now you need to be a little careful that whenever you're putting this in a calculator, after you put the square root, make sure you're using the brackets, because your calculator will take BEDMAS, so you could get a different answer if you don't do that. Now what I'll do is I'll go ahead and then again do the same thing. So label my x1s and y1s. So I'm going to write, say, this guy as x1, y1, and I'll write the center as my x2, y2. I'll use the red ink for now because it'll probably be the last step that I'll be doing in this video. So the distance is x2 minus x1. So I've got 20 minus 15 the whole square plus, within the brackets, 27.5 minus 30 the whole square. So if you put this in a calculator, you should be getting maybe 11.25 units, and that's the radius of your end circle. I hope this video was helpful. Do let me know if you've got any questions in the comments. See you in the next one.